Welcome. In this video, we're going to see how we can import systems that have been designed in various plant design products, such as Autodesk Plant3D, CADWorks, Smart Plant, and many others. This is mainly basically done through the interfaces, specifically PCF import. PCF is a file that's used to generate isometrics, so pretty much any plant design product that can generate ISOs will have the capability to generate a PCF file. And CloudCalc is able to read this in and process it in a fairly intelligent way. And we'll demonstrate how to do that today. Specifically, we'll be using the AutoCAD Plant3D product. Here's a drawing. It's a very small plant facility, a number of pipelines in here, for example. Okay, 2002 is one, 2005, 2009. We have here. Most plant design products, as I said, have the capability of generating a PCF either by generating an isometric or going directly cutting out the final end product and exporting to a PCF file. So we'll do this here. We'll click Export to PCF. The various line numbers that are available are here. We pick out which ones we want, tell it where we want to save the PCF files to. In this case, Plant3D CloudCalc folder. Hit Create. It'll go through and generate those files for us. You go over to CloudCalc to bring them in. You go to CloudCalc. You say Interface is PCF import, and you go to pick the file that you want. It's going to be Plant3D CloudCalc. And here they are here. But before we do that, let's bring one in. Let's look and see what it should look like. I believe this, well, let's bring this one in first. It's line number 1002. Let's go ahead and add the rest of that line to that selection set. Go and isolate that. And we should have a system that looks like this. Flange, elbow, valves, T's, various types of things, an anchor here in the middle, etc., connected to equipment, which we presume is going to have some sort of imposed displacements. So this is going to be line number 1002, which if we go over to CloudCalc and we select 1002, the first thing we do, this is going to overwrite whatever model you're working in. So let's give it a new job name. Call it PCF. Go select this interface PCF import, bring it in, and it'll process, bring it in. The first thing it'll do is give you a number of error and warning messages. Things such as if we weren't able to pull the material off of here, we'll default and use a A53B. It's up to you to go in and change the material of the different components. It tells you the end position, such as where we saw is attached to equipment, are going to be created as displacements. Displacement set 1, and they're preset to 0, 0, 0, 0 because we don't know what those displacements are. But this means if you don't change that, it'll act as anchors. Otherwise, you can go in and add the imposed displacements if you know that. So we have a number of end positions in here. Also tells you that things such as flanges and valves, if the weight does not come across, then we make a simple unit weight, in this case 1 kilogram weight for each of these rigid items. You should go in and change those. Here we also found out that there were some duplicate items here, the items that more than one. This is probably somebody drawing up that piping system on the other side. Probably put a few components on top of themselves, but we found this. There's a duplicate elbow pipe, a few other pipes, etc., flanges, and we just ignore those. If it's obviously duplicate, we leave those out, but we tell you that, and you can go back and fix those. More about the weights, etc., more duplicate items. If we weren't able to tell the schedule or the wall thickness, we just default to a schedule. That's typically going to be on rigid items where the wall thickness is not that important. And things like that, etc., etc. And you can go through here and we tell you which line each of these things occurred on, etc. And there. So once you're done, you go in and take a look at this. This is what we got you, built you. The T's, the flanges, the anchor, things like that. If we reconfirm our model there, same shape as what we have. Things as I mentioned, we have, we just default to a weight of 1, materials of A53B, but we have the correct restraint type. We have, should have a stress intensification factor here. Let's see where that is. I believe this was an OLET on the other side. So yes, it comes through as a, okay, a fillet weld here for the sockolet, etc. And then just to make sure that it works okay, we can go through and do a static analysis. We'll do an error check and it comes out okay. Obviously, you have to add the fluid, you have to add the temperature, the pressures, etc., because those were not there. So that was the first one we brought in. We can also see what other things we can bring in here. Let's go back to our, this line is 1005. So let's look at the rest of these. That system. Oh, the one thing I forgot to note here is the imposed displacements. If we want to look at those, we can see that sure enough they were imposed where we're attached to equipment, and they came in with a value of zeros, which you can change if need be. So if you happen to know the displacements from the equipment, you can handle that. Okay, next item. We're going to bring in 1002 PCF import. 1005 next. Overwrites whatever model you have. Again, end positions put in as displacements. Other things messages that we've seen before. So there's your end conditions. Next, let's see what's the next one. We want to bring in this one down here, and that's 1009. That system, bring that into CloudCalc, interface, PCF import, 1009. Again, the typical warnings and messages telling you what you have to look out for. Displacements added at the ends. Run the analysis. Okay, goes through the error check. Comes in pretty good shape. Next one. Okay, this is 2525. Something that looks like this, a hanger here in the middle, connected to various pieces of equipment. So if we bring in 2525, again, same sort of messages, alerting you to things that have to be done on your side. And there it is. There's a hanger brought in, etc. The connections here. Let's see if we had any displacements. There were no end conditions programmed into PCF at that point, so you're going to have to put in your own displacements here, or anchors or whatever. So we should probably guess that this one is not statically determinate and will not run without some changes. And finally, the last piping system here is The last line number that we want to bring in is this one, which is 1599. If we bring them into CloudCalc, and positions there that return to imposed displacements, which if we take a look at their locations, here, here, and here, and as mentioned, most of the geometry comes in, the types of ridges, flanges, etc. The T's, if we look at the T's, go to the list view. Okay, welding T's, etc. came in. So the different stress intensification factors, the different component types, the wall thicknesses and schedules. We look at this. So 8-inch schedule 40. Everything comes in. The insulation as well, where it's available, but typically it will not have information regarding the piping loads, such as the temperatures, the pressures. Those are the sort of things you're going to have to bring in yourself. So anyway, this is what we do. And again, this should work with most plant design products. Give it a try, generate your PCF files. If you have an issue, let us know. Thank you.